So good afternoon, everyone, and welcome to today's webinar in our Creo 8 series, where we are going to be looking at the fluid flow capabilities within Creo 8. So with us today to take us through this journey is Applications Engineer from PTC, Paul Dye. And we also have as our panelist, Bill Stickney, who is a CFD and FEA expert. So, Paul, without any further ado, go ahead and take the con, and the show is all yours. If anybody has any questions, feel free to type those into the chat box, and we'll try to answer them as we go.
All right, sounds good. Let me go ahead and screen share right now then. And let me know whenever you can see my screen.
I think we've got it.
There we go.
Awesome. Sounds good. So this is, again, part of our kind of ongoing series we've been running here, going over a lot of the new functionality that we have within Creo 8 and even touching on some of the more recent releases of Creo. And today what we're going to be focusing in on is one of our simulation tools called Creo Simulation Live, specifically into the flow analysis. And overall, just with Creo, really, we have a lot of different tools for simulation, whether it be for your standard structural analysis, which we can do with Creo Simulate, or even with one of our tools that we introduced with Creo 7 called Creoansa Simulation. We can do tons of different simulation, pretty much anything you're gonna wanna run. We're gonna have tools here within Creo for being able to do. We have a tool that we built out through our partnership with Ansys, which I'm gonna be going over here around Creo Simulation Live. And that's really the first place where I want to start here. So this is something that we've had with Creo for quite a while now. I think since the release of Creo 5, we introduced Creo Simulation Live. And if that's something you haven't heard of before, I just want to give a bit of a background into it. It's essentially taking what you would normally have with your simulation, where typically you're going through and you have to build out a mesh and you have to do defeaturing and all of that. Well, with Creo Simulation Live, you don't need to do any of that. It's just something you can run instantaneously. You get results back immediately, and you can do that for structural, thermal, modal simulation. And now with the release, actually in Creo 7, we introduced Creo Simulation Live Plus, which is a huge enhancement. And so with Creo Simulation Live Plus, we now have the ability to do flow analysis in really the same way that you do for structural, thermal, modal. And the setup of those studies is very straightforward. So you're able to, first and foremost, create fluid domains where you can decide which areas that you want to include or exclude from the flow. You're defining the inlets, the outlets, the materials that you want to work with. And then from there, be able to visualize it right on top of the model that you're working with. And this is something I'm going to go through and show a demonstration of. In our case, it's going to be for an internal flow case, but it works well both for internal and external flow cases. And another thing that we'll see with that, a lot of different options for the results that you're getting. You can visualize the streamlines, the particles, take section views, direction fields, set probes to monitor certain values. It's really a very powerful, but at the same time, very easy to use tool for doing this type of flow analysis. So it's not something that you would typically see with flow analysis, where you might normally send off the design to the expert analyst, something that they go through and run for a few days. You get results back by next week. It's none of that, right? We're saying right within Creo, we simply set up the use case that we want to look at and immediately have access to the results. And again, I'll go through and show exactly what this looks like in the context of Creo in the flow analysis, but it also works well for any of your standard structure or thermal or even vibrations. And now with Creo 8, we had, I even guess we should take a step back and say with Creo 7, a lot of the development time in the flow analysis was for transient studies, where the results refine over the course of time. And that's something that we wanted to introduce initially. But we also know that a lot of users want to design for the steady state. So with Creo 8, that's what we added, is the ability to perform these type of steady state simulations from within Creo Simulation Live. So this will actually be the default now, and the user has the ability to switch between a transient state if they'd like to, over to a steady state, but now you have the option to move between those as well. And another thing that we added with the release of Creo 8 was the enhanced probes. So there's a lot of new functionality around these. You have the ability to redefine probes, track different values as you go through and make different design changes, see what that does to your velocity, see what that does to your pressure. So that's something that we've improved throughout the different releases of Creo Simulation Live. And I did want to just take a quick moment to touch on Creoansa Simulation. So this is actually something that we released in Creo 7.0.2. And this is for a little bit more of your closer to validation scale analysis. This is, again, only working with structural, thermal, and modal, but this is something that works with the ANSYS workbench for doing more of your validation analysis. What we're working with in Creo Simulation Live is more of design guidance, more to tell you how the changes that you're making are affecting the model, letting us work into the right direction. And then by the time you might want to do your final validation, once you're starting to get close to that, then you can move over into this tool, the Creoansa Simulation, for doing more of that validation analysis. And it's something that we, again, just released in a maintenance release of Creo 7, but we were still able to make some different enhancements here with the release of Creo 8. So within this, we've exposed certain controls in the model tree for mesh control. So any changes or refinements that you want to make to meshing will now be flagged and identified in the simulation tree. And as well as that, we also have mesh diagnostics inside of our process manager. So you're able to more clearly understand any issues that might occur from the meshing that you're building out. Okay, so again, a lot more detail we could go to into all the different simulation tools that we have from within Creo, a lot of enhancements that we're making in lots of different areas. But again, today I want to focus more on the fluid simulation that we have in CSL. I want to go through and show a demonstration of that. And again, if you have any questions around this, feel free to drop that in the chat box. Either Bill or myself will be more than happy to answer that. And if there's anything that we can't answer, we could definitely reach out and get you some further insight or any other answers that you might need. All right, so let's go ahead and get started here. I'm going to go ahead and open up the data set that we're going to be using for the demonstration. So this is actually going to be for a model of a faucet. So we can go ahead and open that up here. And first thing we can see is that it's a decently complex model. There's a lot of different parts, a few different sub-assemblies that we have from within there. And if we want to get started into this, we'll just simply go up into the live simulation tab. And again, it's not a separate software or even different window that you're using for this. It's all within the same exact user interface that you would see with Creo Parametric, wherever you're building out those models, wherever you're building out your features. That's exactly the same interface that we can do this type of simulation. And in this case here, we're going to be doing a fluid simulation where we have our fluid domain set up there, as well as a few different thermal conditions for our initial temperature in the system. And now what we can do is go ahead and add in some different boundary conditions for our use case. So we'll start here by laying out a mass flow that we'll have coming in our pipe down at the lower left-hand side. And with that, we can give it a value, change the units if we need to. And now we'll do the same thing over here on our pipe coming in on the right-hand side. So we'll have that coming in at around the same rate that we did over on the left-hand side. And once we set up any of those boundary conditions, we can always stop over in the simulation tree here and make changes at any point down the road as well. And now that we have our mass flow defined, I also want to simulate how the system would likely be working out in the real world, where we would probably have a hot and a cold side here. So we'll start here on the left-hand side. We'll give that a starting value of 40 degrees Fahrenheit. So that'll be our cold side. And that means that we'll set our inflow of hot water here on the right-hand side. Go ahead and give that a value of 120 degrees Fahrenheit. All right, and now to finish our setup, we'll define an outlet pressure for the system. In this case, it'll be up here at the spout. And we'll leave that at a value of 0 pascals. And with that, our setup is more or less complete. Now, the first study that I want to go through here and show is going to be in transient mode or time dependent. And then afterwards, we'll also take a look at how that compares to our steady state option. All right, and all we have to do here is click the simulate. And again, as soon as I do that, we immediately have access to the results. So on the model, we can see the velocity of the flow change over the course of time. That time is being displayed over here in the legend. On the right-hand side, you can also see how those velocity values are changing over the course of time. Or another tool that we could use during these studies is a live simulation probe. So these allow us to monitor how certain values are changing over the course of time on particular parts of the model. Here we can see how the velocity is changing throughout the study. We can see a graph of those values here as well. So those live simulation probes work very well here in the flow analysis module, but they also work well with the structural cases, vibrations, thermal. So a lot of great uses that you can get from them while we're designing. And while these transient studies are very useful, again, a lot of our customers that work in this area are very interested in the steady state as well. So that's what we're going to do here, is switch that over in our study settings. And like I mentioned earlier, normally if you wanted to get these type of results back around your designs, we would typically have to send them out to the analyst. It could take hours, days. A lot of times it takes even weeks to get just some basic results back. But that's not what we're doing here. Instead, we say right here within Creo, hit simulate, and within seconds, we can check out the results from the study. So first thing we can see is our max values here in the model. So in this case, it'll be for velocity, but you can change that to pressure, temperature, vortices. So here for the temperature, you can see how those two settle out, some of the values that go along with the system that we laid out. And with any of these results, you can change the render state. So here you can see that composite view where we're only seeing values within a particular range, which we can move around. We can change the bounds for that range, wherever it starts and ends. So really very versatile with those results. And clearly a lot that we can do here with our steady state results to analyze what's going on. But also at the same time, we have a lot of great flow visualization tools that we can work with and utilize here as well. So let's go ahead and check some of these out. The first thing that we can see is a direction field, which acts as a movable plane where we can see the direction of the flow at different areas throughout the model. And again, we can adjust that over to the X plane, the Y, the Z, or anywhere in between there. We could also take a look at the streamlines that we're getting as they move throughout the faucet, which can be a really great way to see if the model is working as intended, whether that be for an internal flow case or also even for external flow cases. You can see the particle flow through the faucet, and with any of these, a lot of different display options, a lot of different parameters and options we could change to really get a much better understanding of our use case and see exactly how well our model or our faucet is functioning. All right, so that's all we have to go through there. So you can see fluid flow capabilities with Creo Simulation Live are very quick to use, very easy to use. It's really a great tool for designers, for engineers. You do not have to be a CFD expert to get some great insight into your designs. And so now with Creo 8, be able to do that with the steady state as well. All right, so that covers what I wanted to go through and show for the flow analysis within Creo Simulation Live. Again, an awesome tool for designers, but with that, we can go ahead and pass it back over if there's any questions that you might have, any insight that you'd like Bill or myself to give around any of these different areas, or even anything outside of the CSL flow analysis. We'd definitely be happy to do that now.
Cool. Thanks, Paul. So, Bill, if you have any comments or anything that you'd like to add, feel free to. But before Bill gives any comments or thoughts, just one of the things that we do as a company is for everybody who has a license of Creo or a CAD license with 3HTI, we provide a 1 hour session of desk side coaching. And if you only have one license, we'll give you 2 hours. So it's 1 hour per license, but we give you 2 hours if you only have one license, if that makes any sense. So anyway, what we want to do is we want to help you become proficient at using Creo, and what you don't know what you don't know. So if there's a way that we can help you design faster, model quicker, or using a product like Creo Flow or Creo Simulate Live in a faster manner, then we're more than happy to help you out. That's exactly what that's exactly why we're here. We're here to add value to your business. So Bill, any final thoughts?
Well, this is a great tool for designers. What I find in the thermal world is a lot of what you do is, for example, if you have electronic cooling and you have a heat sink, how many fins do I need? Or what spacing do I need here and there? Very, very basic questions. And if you can refine that, you're going to be a lot closer to the right answer when you go for your qualification analysis. It saves oodles of lab time and saves a lot of real time getting product to market. So this is good stuff. And it is easy to use.
Excellent. So if anybody wants a more specified demo, feel free to get in contact with us. Our email is info@3hti.com. You can respond to me via the emails that you received, inviting you to the webinar, responding to any of those. Those emails come to me. And we're more than happy to give you some more detail and make sure that this product's a fit for what you're doing. So I want to thank Paul for being on today. Paul will probably be on again next week at noon. Next week we're going to cover the usage of Creo 8, just the layout, the usage, and the updates regarding the usability of Creo 8. The following week we're going to cover topology optimization. And then the following week after that, we're going to have Bill do a demonstration on Creo Flow. So we'll keep our Creo series running this summer. And once again, if you have any questions or need anything, feel free to contact us, and I will be sending you an email with the recording to this webinar. Thank you, Bill. Thank you, Paul. And most importantly, thank you to our audience for being on today. Everyone's dismissed. Have a great day, everyone.